Hi guys, welcome back. So we'll be treating this question, this physics question. It was actually from the past question, UTME past question. So the question goes thus: are two objects, one having 3 times the mass of the other, are dropped at the same time from a tall building. When they are above the ground, the two objects will have the same. So we have our options: momentum, kinetic energy, potential energy, and energy. So for this kind of question, you may decide to use the normal route of when you are trying to deal with a calculation question, and then you look for the diagrammatic representation of the question, and then you do that. But then just to save our time, what you just have to just do is, since the thing that there's a particular parameter that is different for the two objects, although we are still going to most likely still have calculation. So let's just use the long route. So draw the diagrammatic representation of the question. So you have two bodies, let's say X and Y. This one having 3 times the mass of the other. Both of them are dropped from the top of a building. Pium, pium. So now they're not asking that what are the parameters both of them will have in common. So the first thing you need to do is identify the parameters that you are given in the question. Now we're given mass. Now that from mass, it seems to everybody that there's no other parameter that we're given, but then we are given the initial velocity because they said that they are both dropped from top of building, and for them to be dropped, that means the initial velocity is what? Is 0. So you have ux to be 0, you have uy to be equal to 0. Now we are looking for what? The final velocity, vx and vy. What else are we given? Any object that is acting under gravity. Any object that is acting under gravity, like when you are trying to drop a pen from top of a building now, or whatever it is, so far is within the Earth's gravity, it will have an acceleration due to gravity. So we're also given acceleration to gravity, which is what? 10 meter per second square. It's actually 9.81 meter per second square, but let's use 10 for easy calculation. So now that we're given, now that we got that, now let's calculate our vy and vx. So we're given this, and then don't forget that since it is from a tall building, so that means there'll be a distance covered. So that means we are also given s, and don't forget that the s for this will also be the same s for this, but both of them are covering the same distance. So we have our s, we have our a, we have our v, we have our u. Each equation of motion, uniform motion, links all of this together. We have what? V square equals u square plus 2as. So let's do this. So for v, let's start with for vx squared, you have u is what? 0. So you ignore that. Then times 2 times 10 times s. Let's leave s as that. So you have vx squared equals 20s. Just not to waste your time. So just have vx equals to a square root of 20s. So not to waste your time. It's basically the same process for vx and vy, but then just do it. Just so you'll be wowed, you'll be amazed. So you have for vy now, you have vy squared equals 2 times acceleration to gravity is what? Is also 10 times what? Times your s. They are both covering the same distance. That's for vy. So your vy squared will be equal to what? 20s. So your vy will be equal to what? Square root of 20s. So you realize now that vx and vy will remain the same. Both of them will have what? The same final velocity. So the parameter or the quantity that both of them will share, that they will have, that will be the same, is what? Is the final velocity. Now, but then let's just go over the options that we have, because most times in an exam, you do not necessarily have to go through the long route because you are fighting against time. So sometimes you have to just do elimination method. So let's start with the momentum. So momentum, when we're calculating momentum, is what? Mass times velocity. Now, since there is mass here, so that means both of them cannot have the same momentum. They cannot have the same momentum because they have different mass. Because by the time we calculate the mass, one has 3m, one has single m. So 3m times v will give us 3mv. M times v will give us mv. So it's not the same. The same for kinetic energy. For calculating kinetic energy is what? Half mv squared. Since there is m there as well, so you don't need to even stress yourself. Any quantity that you need to calculate for either of the objects that has mass in it, just know that they will not be the same because the mass of both objects are not the same. So none of these options are correct. The correct answer is what? Final velocity. They will have the same final velocity at the end of the journey. So I hope you understand that. See you guys in my next video.